We will now be moving into Section 5.9, Quality Assurance and Data Validity. We will also discuss quality control in this section. You must have quality control procedures. These should be incorporated into both your quality manual for generic quality control, examples being blanks, laboratory control samples, and matrix spikes. And more specifically, these need to be defined in your SOPs and methods, including all acceptance criteria for quality control. Quality control data must be recorded in such a way as trends are detectable. In the past, this was always done by control charting, either by hand or with Excel. These are still valid ways and give a great visual result. But it could be that your LIMS system can do this for you, or you may have produced another way to do this. Be able to show your assessor whatever it is you do to evaluate trends in your data. If your data doesn't meet quality control requirements, you must investigate what happened. There are several reasons why a quality control might fail or may not meet the set requirements. Regardless, you'll need to investigate before continuing with your work. This is a great opportunity to look to your non-conforming work procedure, as it will include information on what to do in this scenario. You might also look to the method or the SOP. Predefined corrective actions can and should be included in your SOP, and potentially even in your quality manual. An example may be that a blank or an LCS fails, the batch will be automatically reanalyzed. Remember, if you have an ongoing nonconformance, it becomes something that needs a corrective action. My go-to example is always BODs. A random BOD blank or GGA failure is to be expected, but the moment you notice a trend, it becomes something that needs a detailed investigation and corrective action. T&I has some added language on quality control procedures. Labs will need a written protocol for monitoring all of the quality controls noted on the slide, including positive and negative controls, appropriate calculations, variability and repeatability, appropriate standards and reagents, accuracy, including calibrations, proficiency testing, certified reference materials, and etc., selectivity, method capability, including limit of detection and linearity, and constant and consistent test conditions. Labs must also assess and evaluate quality control on an ongoing basis and have appropriate acceptance criteria defined. Labs must have a procedure for the development of their acceptance criteria if one does not already exist for a method or from a regulator. Remember, the lab must follow the most conservative or most strict requirement. This applies here for quality control as well. If T&I has the most rigid requirements, then the lab should be working with those. The assessor will be auditing you to whatever is noted as the most stringent. The most common pitfall in this section is not following the most stringent quality control requirements. At times, it can be difficult to ascertain which requirements are most stringent. Since California has thus far been mostly method-driven, a rule of thumb would be to not drop anything you're currently doing and add any additional requirements the standard may have. Once you've determined what, if anything, needs to be changed, add it to your SOP and then follow your SOP.